Before I'm gonna start to talk about the topic, I would like to ask you, what would that feel like if technology and sustainability and well-being seamlessly come together? Of course, that you guys may come up with a different answer, but to me, I personally think that technology should drive sustainability and well-being, not just convenience. And here is some example that I'm trying to search the uh, innovation or products that actually can sync between the well-being, sustainability, and technology. The first one is called Prep Hubs. And the Prep Hubs are modular self-sustaining shelters designed and developed by MIT. And this is supposed to be a disaster shelter that can support people during the disaster event. And its function is can provide a clean water, and also people can get the latest information about disaster. Of course, it's designed to be the off-grid, so it can be operated under the disaster situation. And the next one, I'm going to show you the Sidewalk AI, and this AI is quite interesting in terms of how that can help people to have a better life within the cities. This AI can work seamlessly with your smartphone symbol, and it can analyze the pavement type, the obstacles, the slope, and the length and width of the street. This is not only be very useful for the wheelchair persons and also blind person, but in terms of the urban planner, this can be the very powerful tools to help us to analyze and understand the pedestrian situation in the cities. And the next one, it called autonomous bicycle. This one is quite interesting that they changed the way that the bicycle work. They design a tricycle mode for a bike to go around by itself in autonomous mode, because the user can book and make a reservation through the app, and then they can a bike can go directly from the station to the location where the user call, and then once a rider want to ride it, it will turn to be the basic mode of the bicycle. Just change for the tricycle to be the conventional bicycle, so user can ride normally. And this is quite interesting that how technology turn the daily routine into different ways. And the next one is the product that our team developed by ourselves. It's called Farsight. It's an air purifier tower which can provide air quality data for the outdoor, and also can clean up the air within the area. That can help people to go out to do the outdoor activity during the PM 2.5 season. That, of course, like previous speaker already mentioned that for Thailand right now, it seems like every month, every season is turning to be the PM 2.5 season to me. And I think this product is going to be one of the devices that can help people have a better quality of life. And that's all from the example that I'm trying to show. But I'm going to move forward into my topic. My background is architect. Of course, I'm basically focused on the building scale. And on this sentence that I heard from Winston Churchill quote, it's totally changed the way that I work as an architect forever, because this is quite classic and touched to my work. He said that we shape our buildings, thereafter they shape us. So it's not only about design, aesthetic, and function, but I realized that the way that we build a building is actually impact our health. And to think about the reality, I quite agree with this sentence, because we nearly spend about 90% of our time indoors, even though you are office worker, you are student, you are lecturer. And if you live in the urban context, it seems like everyone got the same situation, but because we spend our time indoors, and how that influence our overall health. Just want to show some very quick and basic example. Like if you read a book in the low light level, that's going to be eye strain for you. And if you drink contaminated water, that's not going to be good for your body for sure. And if you breathe in the PM 2.5 or some toxic chemical from the building materials like VOC, that's going to be bad for your respiratory system. And this is just a very, very quick example that how the built environment actually impact our health. Just an easy example. But once my team, we are diving into the details and study further about the environmental factors that can lead to the risk of the disease. We found out that NCD is quite interesting because in NCD, non-communicable disease, is quite different from the other types of the disease. It's not like COVID that you got bacteria or virus, but this kind of disease is a result of the behavior. If you consume something healthy, your body will be healthy. If you consume something unhealthy, your body will be unhealthy. That's not surprise. But the surprise part is that environmental factors actually have a very, very high impact and associated with the risk to diabetes, stroke, kidney disease, and hypertension or cardiovascular disease, for example. And I think PM2.5, asbestos, VOC, formaldehyde, light, level, temperature, noise, and pesticide. All of these factors actually we can find it in our daily life is surrounding us. And I think this is quite interesting information that we have to let and create the awareness among the public to be aware of these factors. And the question is that, of course, I'm saying that built environment actually impact our health and how to deal with it, how to make a better healthy building. And actually right now, there are several types of the building standards that focus on the well-being. You can use like a W.4 standard, fit well on nine foundation of a healthy building developed by the Harvard University or the SOC standard, which is a Thai version of the building standard for well-being. All this standard can guide the designer, the project, the developer to start to think about the health impact once we develop a building. And I'm gonna dive in a little bit and talk about the WELL-V2 a little bit about how would it connect with the technology, because basically the WELL standard have 10 concepts, but 5 of them can be better. We can make a better performance of these 5 concepts: air, water, light, thermal, and sound. If we integrate the appropriate technology, then it could be very, very benefit to the owner, client, or the tenant, or the occupants. Because today I think we don't have much time to go all over 5 concepts. I'm going to bring back some quick example to demonstrate the example of how the technology can link with the well-being for people. Starting with the air concept, believe it or not that each day we eat about 1 kilogram of food and we drink about 2 kilograms of water, but we breathe about 20 kilograms of air. And you may heard the sentence like you are what you eat, right? It's a classic statement, like if you eat something good for your body will be last longer. And it's the same way with the air. So all these factors actually link with the risk of NCD, which I already showed you from the diagram earlier. All these factors actually affect our body. And to think about the source of poor indoor air quality, actually we have different types of the source, but I would like to touch about the biggest proportion inadequate ventilation is actually accounting for 52%, and the contamination from inside the building is about 16%, and the contamination from building material is about 4%. Just only these 3 sources, which is the one that we can control, we can improve it. The other 3, I suppose that is something that we cannot control it. But these 3 factors is actually account for 72%, which if we want to improve the air quality, this is something that we should pay attention. And I would like to refer another phrase from Rod Kelvin that if you cannot measure it, then you cannot improve it. Just to confirm that if you really want to care about the air quality and to improve the air quality, the best way is to measure it. And I would like to mention about the IAQ sensor, because this is one of the part of the WELL requirements that each building, each project should consider to install the IAQ sensor. And the benefits of the IAQ sensor is actually plenty of the benefit to different stakeholders, but I would like to start to talk about the real-time air quality data. This is quite very important and give the benefit directly to the occupants or users, because we can know the real-time data. We can know like what is the level of PM2.5 within the building. I think right now it's quite easy for us to get the PM2.5 data for the outdoor environment. We can look at on the application or on the internet, but once we enter into the building, it's quite hard for us to make sure that what is the PM2.5 level. Some people wear the mask when you go outdoor and remove the mask once we enter the building, but how can we know that the indoor environment is better than outdoor? Because basically the indoor environment is getting worse 5 times comparing with the outdoor. And of course, once we get the data, and if we can use that data to sync with the smart building system, of course, the system can adjust the airflow to let it work appropriate volume with the demand within the room. And we also can detect the early sign of the building system malfunctions. If something gonna be broken, and then we can detect it at the early stage, then we can fix it quickly. That's going to be very good for the entire system. And of course, if we understand the patterns of how does it work, then we can optimize the energy use and leading to the lower operation cost. And this point, I would like to show you a very quick example and calculation that how can IAQ sensor can contribute to the budget saving in terms of the scenario of a meeting room, a size of 100 square meters. This is just a very for an easy number for calculation, but I'm not going to go for all of the details, but I'm gonna show you that if we can understand the demands or the airflow of the room, then we don't need to turn it on with the full capacity all of the time. Because if we can change the speed, change the airflow volume, we can save about 3 times of the energy consumption of the building. And this is just a very quick calculation for just one loop. And the next topic I would like to talk about is the natural light. Believe it or not, that the 2 highest energy costs of a building is actually coming from the HVAC system, which is the air conditioners for the building, because we are a hot and humid country. And the second system that consumes a lot of energy is the lighting. And both HVAC system and lighting system is actually have a very huge impact from the sunlight and daylight, that the way that we design the building. Because if we can design the building that receive less heat gain, which means that the HVAC system can work better, consume less energy. And at the same time, if we can utilize the daylight to let the daylight access to building, which meaning that we don't need to turn on the artificial light on the daytime, then as a result, we can save more energy. And it's not only about the energy point of view, but I think the lighting system actually related with the circadian rhythm, which is a biological clock within our body. The way that we produce some kind of hormone, melatonin, is quite related to the daylight that we perceive during the day. And if we spend our time within the building that's designed the wrong types of the lighting, which meaning that it can be disturb our patterns. So our body cannot realize what is the time. For example, like if we work for overtime in the night, but we still get the lighting level within the building for like daylight level. So our body will feel like, okay, you still have to be energy, you have still to be alert, something like that. So it's gonna be affect with the sleep patterns, which will come up with a lot of risk for the disease later. So lighting is quite important. And I think another point of view of the sensor, we call it the daylight sensor, it can be very, very helpful for the project as well, because of course, the way that we design the daylight sensor, it can help to promote daylight access. If you see from the diagram on the right hand, you can see like the amount of the light from the light fixtures that nearby the window will perform less than comparing with the one in the middle and the one in the far back, because people get enough light from the window, from the daylight access. And all of this can be a result in save the energy bills, because we need less energy demand from lighting, and also can improve the building performance, and also can support the circular living because people get access more to the daylight, which leading them to the better sleep patterns. That's the benefit of the daylight system. And I'm going to show you again the example of how the daylight sensor can help the building owner to save more in terms of the bills. And I assume that if you're thinking about a room size of 100 square meters, install the LED that consume about 10 watt per square meters. And putting in the data for the Thai context, that electricity cost for us is about 4 baht per kilowatt hour. And this room operate about 12 hours per day. Then the energy saving ratio comparing with the standard LED lighting and the LED lighting with the daylight sensor. The daylight sensor can help the owner save about 30% less of the electricity cost. And again, this is just a one calculation for one room. But if you think about the real scale of the building, it actually can have a huge impact that can be very, very good benefit for the client. And to close up my presentation today, I would like to say that the future is in our hands. So let's build it wisely together. Thank you, Kap.